So for Chris and my project, we decided to look at an article entitled "The Social Impact of a Robot Coworker in Industrial Settings." The idea was that there's been a trend lately towards collaborative manufacturing machinery as opposed to traditional machinery where it's in a separate room because it's not safe to work alongside. Collaborative manufacturing machinery is designed to be worked directly alongside with a human employee. However, there's been little research in terms of the social impact of these new types of machinery in the workplace. So the authors presented two bits of prior research they found relevant to this study. The first involved how people interact socially with technology. What it found is that when technology attempts to mimic people more accurately, people tend to interact with the technology as if it were human as well. For example, something like Siri, people converse with Siri. People include elements of human conversation when they interact with Siri. That's different from when they would interact with a different type of speech recognition software. The other is perception of day-to-day machinery. And what this study found is that the machinery people deal with on a daily basis, they tend to build a relationship with it. On the left, you can see two Roomba vacuums that have cases that look like shells because people take pride in the Roombas. People like their Roombas. And on the right, there's the Snackbot at Carnegie Mellon University. This was particularly interesting because the people there they assigned human characteristics to it that obviously were not real because it was a machine. And the side effect of this is that because they were interacting socially with this machine, they were interacting socially with other people in the dorm as well because they had a common conversation topic. So for this study, the authors decided to look at this particular piece of machinery called Baxter. Baxter is a manufacturing robot. He's got a humanoid shape. He has as you can see, two arms to manipulate objects. It can pick things up, put them down, move them around. And it has a screen, probably one of the more noticeable features, that has eyes on it to sort of give it more of a humanoid feel to it. It's safe to use alongside people, so it is this type of collaborative machinery. And it's meant for pick up and place tasks. So it might take an object from a conveyor belt and move it into a packaging area, or take it from a conveyor belt, moving it to another conveyor belt, etc. And it can be integrated into a system. So it can tell the conveyor belt to slow down because it's receiving too many objects. It can tell that it's moved something into a package that needs to be picked up. So it can communicate with whatever system is already in place. In designing this study, the authors looked at 3 different businesses that all used the Baxter robot. 2 of them were small, under 50 employees. The final one was a larger international business. At the specific factory they looked at had 150 employees, and each Baxter model was dedicated to doing a single task. The first, at Company 1, as you can see in the left picture, was dedicated to moving stacks of cups from a conveyor belt. The second, at Company 2 on the right, was preparing waterproofing tubes for electrical wire. And the final one, at Company 3, was packaging hardware for furniture. For example, brackets you would find packaged with your IKEA furniture. As for data collection, there were several different types of data being collected, including the reasons the robot was purchased in the first place, the process of integrating the robot into the workspace and how difficult that was, how difficult it was to reorganize the workplace in the first place to accommodate the robot. For your example, did the company have to change their workflow at all? And lastly, just how workers perceived and interacted with the robot. And then lastly, they collected data in 2 different ways. There were fly-on-the-wall, more candid ways of data collection, and there were interviews with on-site stakeholders. The stakeholders were the managers, people who bought the product and who created the goals for the company. There were the maintenance workers who fixed, programmed, and troubleshooted with Baxter. And then there were the operators, so people who worked in the workstation directly with or alongside Baxter.
The findings of the study can be split into 2 groups: social interactions coworkers had with Baxter, and Baxter's appearance. Coworkers found that social interactions with Baxter were generally positive. They believed Baxter was friendly, and claimed to have social relationships with him. Many of these interactions took place, though, when Baxter was malfunctioning. Coworkers found that communication with Baxter was limited, and tended to frustrate them because they had no way to speak to him. Many found themselves either musing at Baxter as to why he had stopped working, or angrily complaining at him because he had stopped working. Coworkers felt, as a result, that Baxter needed to be supervised throughout the workday. They described him as annoying and childlike. Maintenance staff didn't interact with Baxter this way, though. They generally treated Baxter as another piece of machinery because that's how they interacted with it. Both maintenance staff and coworkers agreed that a speech interface would have been more useful. Baxter's appearance was a positively received part of the machinery. The human attributes were generally considered helpful when attempting to get coworkers used to working with a collaborative robot. One of the especially helpful features was the eye signaling Baxter incorporated. Baxter's eyes would signal where his arms were going to move, and this was especially helpful for new coworkers because they were not used to anticipating Baxter's actions. The study had several conclusions about collaborative robots in the workplace. They found that Baxter had a generally positive effect in the workplace, but they found that Baxter lacked in several areas, one of which was social interaction. The study found that social interaction was a very important part of collaborative robot design. This is because coworkers have expectations that need to be met in the workplace. These involve communication and conversation. More support needs to be included in future designs for this kind of interaction. The study also found that human-like appearance was very helpful in facilitating these type of interactions, and that also should be included in future collaborative robot design. We have one major concern with the study. That concern is that there was only one appearance used when gathering data about social interactions between collaborative robots and coworkers. We believe that it's important to have a variety of different appearances when gathering this data to better understand the relationship between the appearance of a collaborative robot and social interactions that human coworkers have with it. We suggest that future studies use robots with no human characteristics to see if the appearance of human-like characteristics increases the amount of social interaction a coworker has with it. It's also possible that more human-like robots can be used, or human-like robots with different characteristics. The study also notes this as a limitation, and generally notes that different morphologies should be used in future studies.